in the last video, we were able to find the equation for the regression line. For these 4 data points. What I want to do in this video is figure out the r squared for these data points. Figure out how good this line fits the data, or even better, figure out the percentage, which is really the same thing, figure out the percentage of the variation of these data points, especially the variation in y, that is due to, or that can be explained by a variation in x. So to do that, I'm actually going to get a spreadsheet out. I actually have tried to do this with a calculator, and it's much harder. So hopefully this doesn't confuse you too much to use a spreadsheet. And I'm going to make a couple of columns here. And spreadsheets actually have functions that'll do all of this automatically, but I really want to do it so that you could do it by hand if you had to. So I'm going to make a couple of columns here. This is going to be my x column. This is going to be my y column. This is going to be the column, I'll call this y star. This will be the y value that our line predicts based on our x value. This is going to be the error with line, So it's going to be the difference. Let me call it the squared error with line. Actually, let me just do the error with line. I'll do the squared error. I don't want this to take up too much space. Squared error with line. And then the next one, I want to do the squared error. Actually, no, I already had the squared error. And then the next one, I'm going to have the squared variation for that y value. For this y value, squared from the mean y. And I think these columns by themselves will be enough for us to do everything. So let's first put all the data points in. So we had -2, -3. That was one data point. -1, -1. Then we had 1, 2. Then we have 4, 3. Now, what does our line predict? Well, our line says, look, you give me an x value, and I'm going to tell you what y value I'll predict. So when x is equal to -2, the y value on the line is going to be the slope. So this is going to be equal to 41 divided by 42 times our x value. And I just select that cell. And just a little bit of a primer on spreadsheets. I'm selecting the cell D2, I was able to just move my cursor over and select that. But that tells me the x value minus 5 over 21. Minus 5 divided by 21. Minus 5 divided by 21. Just like that. So just to be clear of what we're even doing, this y star here, I got -2.19. That tells us that this point right over here, is -2.19 right over here. So when we figure out the error, we're going to figure out the distance between -2 and -2.1. Between -3, that's our y value over here, between -3 and -2.19. So let's do that. So the error is just going to be equal to our y value, that's cell E2, minus the value that our line would predict. And we want just that value is the actual error, but we want to square it. So we want to square it just like that. So we will square it. And then, let me make sure I did the right thing. Yep. And then the next thing we want to do is the squared distance. So this is equal to the squared distance of our y value from the y's mean. So what's the mean of the y's? Mean of the y's is 1/4. So minus 0.25, which is the same thing as 1/4. And we also want to square that. Now, this is what's fun about spreadsheets. I can apply those formulas to every row now. And notice what it did when I did that. Now all of a sudden, this is the y value that my line would predict. It's now using this x value and sticking it over here. It's now figuring out the squared distance from the line using what the line would predict and using the y value, this one. And then it does the same thing. Over here. It figures out the squared distance of this y value from the mean. So what is the total squared error with the line? So let me just sum this up. The total squared error with the line is 2.73. And then the total the total variation from the mean, the squared distances from the mean of the y, are 22.75. So let me be very clear what this is. Let me be very clear what this is. So let me write these numbers down. So our squared, I'll write it up here so we can keep looking at this actual graph. I'll write it over here. So our squared error versus our line, our total squared error, we just computed to be 2.74. I rounded a little bit. And what that is you take each of these data points, vertical distance to the line. So this distance squared plus this distance squared plus this distance squared plus this distance squared. That's all we just calculated on Excel. And that total distance is that total squared variation to the line is 2.74, or total squared error with the line. And then the other number we figured out was the total distance from the mean. So the mean here is y is equal to 1/4. So that's going to be right over here. So y is equal to 1/4 is going to be right over, this is 1/2, so right over here. So this is our mean y. Let me draw it a little bit neater than that. This is our mean y value. This is our mean y value, or the central tendency for our y values. And so what we calculated next was the total error, the squared error from the means of our y values. That's what we calculated over here. This is what we calculated over here in the spreadsheet. You see it in the formula. It is this number, E2 minus 0.25, which is the mean of our y's, squared. That's exactly what we calculated. We calculated for each of the y values, and then we summed them all up. It's 22.75. It is equal to 22.75. So if you wanted to know, so this is essentially the error that the line does not explain. This is the total error. This is the total variation in the numbers. So if you wanted to know the percentage of the total variation that is not explained by the line, you could take this number divided by this number. So 2.74 over 22.75. This tells us the total, or the percentage. This tells us the percentage of total variation, not explained by the line or by the variation in x, by variation in x. And so what is this number going to be? What is this number? I could just use Excel for this. So if I'm just going to divide, so I'm just going to divide this number divided by this number right over there. I get 0.12. So this is equal to 0.12. So this is equal right over here. This is equal to 0.12. Or another way to think about it is 12% of the total variation is not explained by the variation in x. The total squared distance between each of the points, or their kind of spread, their variation, is not explained by the variation in x. So if you want the amount that is explained by the variance in x, you just subtract that from 1. So let me write it right over here. So we have, so our r squared, which is the percent of the total variation that is explained by x, is going to be 1 minus that 0.12 that we just calculated. 1 minus that 0.12 that we just calculated, which is going to be 0.88. So our r squared here is 0.88. It's very, very close to 1. The highest number it can be is 1. So what this tells us, or a way to interpret this, is 88% of the total variation of these y values is explained by the line or by the variation in x, And you can see that. It looks like a pretty good fit. Each of these aren't too far. They're definitely much closer to this line. They're definitely much closer to each of these points are definitely much closer to the line than they are to the mean line. In fact, all of them are closer to our actual line than to the mean.